Hello students, let us continue the session on trigonometry. In the previous session, we had discussed trigonometric identities. We had three important trigonometric identities. In today's session, we shall solve exercise 8.4 with the use of those three trigonometric identities. The first question here is to express the trigonometric ratios sin A, secant A, tan A in terms of cot A. We need to express in terms of cot A. First, I'll consider sin A. I would like to express sin A in terms of cot A. For doing so, I will rewrite sin A as root of sin square A. We know sin A is nothing but the reciprocal of cosecant, so it becomes reciprocal of cosecant square A under root. We all have learned an identity. We know that 1 plus cot square A is cosecant square A. I'll make use of that. So it becomes a root 1 divided by root of cosecant square A. Now in the place of cosecant square A, let me substitute, and root 1 value is 1, so it becomes 1 divided by root of 1 plus cot square A. Hence we have expressed sin A in terms of cosecant square A. I'll just mention that sin A is 1 upon root of cot square A. Now the second question, we need to express secant A in terms of cot A. For doing so, I will write secant A as 1 upon cos A. Now I know that the ratio cos upon sin will be cot. So what I do is 1 upon sin A, I'll consider I am dividing both numerator and denominator by sin A. So I get 1 upon sin A divided by cot A. Now this particular thing is to be converted as cot A. Now this can be written as 1 by sin A multiplied to 1 by cot A. Now in the previous one we had sin A as 1 upon root of 1 plus cot square A. I'll substitute that in this particular thing. 1 upon, it becomes the numerator, and it becomes 1 plus root of 1 plus cot square A divided by cot A. This is how we convert secant A in terms of cot A. Third one, very simple, tan A to be converted. Tan A, we know that it is reciprocal of cot A, so hence this is only the solution. Second question is also similar to the first question. In the second question, they are given write all the trigonometric ratios of angle A in terms of secant A. You need to express sin A, cos A, tan A, secant A, cosecant A in terms of secant A. So what I require is, first I'll convert sin A in terms of secant A. We all know that this can be written as root of sin square A. So it can be 1 minus cos square A Using the identity 1 is equal to sine square a plus cos square a. So I have used one identity now. Now I know that cos a is nothing but 1 upon secant a, so it becomes 1 upon secant square a. Now take the LCM, we get under root, the LCM is secant square a, we get secant square a minus 1. Now if the root is taken to both numerator and denominator, we get it as root of secant square a minus 1 divided by secant a. Hence we have expressed sin a in terms of secant a. The first part is done. Now let us take the second one. Second ratio is cos a. Now I'll express cos a as secant a. Second one, cos a. It's a reciprocal of secant, so it is 1 upon secant a. So that's all. Third one, third ratio is tan a. We know that 1 plus tan square a as secant square a. So I will write this as root of tan square a, so that I can write this as secant square a minus 1, because 1 plus tan square a is secant square a. So the three ratios are expressed now. The fourth one, cosecant a. How do we express cosecant a in terms of secant a? I'll write this as root of cosecant square a. Now we know the identity 1 plus cot square a is cosecant square a. So I have replaced cosecant square a as 1 plus cot square a. Now what do we do with cot square a? This cot square a I can rewrite as 1 by tan square a. Now tan square a we have expressed as secant square a minus 1. The same concept I can use it here. It becomes root of 1 plus 1 upon secant square a minus 1. Take the LCM. We get secant square a minus 1 added to 1 divided by secant square a minus 1. Observe, we get minus 1 and plus 1 getting cancelled. Root of secant square a is secant a, and denominator will become root of secant square a minus 1. That's how we have expressed cosecant a as secant a divided by root of secant square a minus 1. Now let us express one more trigonometric ratio, cot a in terms of secant a. Now I'll take cot a. This is the fifth trigonometric ratio, cot a. This is root of cot square a. Now I will express cot square a as 1 by tan square a. We all know tan square a can be written as secant square a minus 1. Take root on both numerator and denominator. We get root 1 divided by root of secant square a minus 1. Root 1 is nothing but 1. We get 1 upon secant square a minus 1. This is how we express cot a in terms of secant a. Thus we have expressed all the trigonometric ratios in terms of secant a. Let me write the last final step. Sin A, when expressed in terms of secant A, we get root of secant square A minus 1 divided by secant A. Second one, cos A can be written as 1 by secant A. Third one, tan A we have expressed as under root secant square A minus 1. Fourth one, we have expressed cosecant A as secant A divided by root of secant square A minus 1. And the last cot A we have expressed as 1 upon secant square A minus 1. This is how we get the conversion. For the practice purpose, you can try expressing all the trigonometric ratio in terms of sine, in terms of cos, in terms of tan, and so on. Next question. In this question, we have got the combination of trigonometric identity as well as complementary relation. So let me take up the first one. In the first one, they have given sine square 63 plus sine square 27 divided by cos square 17 degree plus cos square 73 degree. I'll make use of the complementary relation. So sine square 63 I'll write as it is, but then this sine square 27 I'll rewrite as cos square of the complementary 90 minus 27 degree divided by, I'll express the first one as it is, cos square 17 degree plus, instead of this cos square 73, I'll consider the complementary, so I need to write sine. Here it should be sine. So sine square, the complementary is 90 degree minus 73 degree. So this becomes sine square 63 plus cos square 63 divided by cos square 17 plus sine square 17. We all know that sine square theta plus cos square theta is 1. So it is 1 by 1. This will be 1 only. So the first one is done. Let's take up the second one. In the second question, this sine A I will rewrite as cos of 90 degree minus 25 degree multiplied to cos 65 plus the cos 25 degree I'll write as sine of 90 degree minus 25 degree into sine 65 degree. So all the angles now they are the same. In terms of 65 degree I have expressed. So this is nothing but cos 65 multiplied to cos 65 plus sine 65 multiplied to sine 65. It is same as cos square 65 plus sine square 65, and this will be equal to 1. In these two questions, we have used sine square theta plus cos square theta equal to 1. This identity we have used. Question number 4. In the fourth question, we have to choose the correct option and justify the answer. First one is 9 times of secant square A minus 9 times of tan square A equal to, I think the correct answer is B. Let's find it out. They have given that 9 times of secant square A minus 9 times of tan square A. If I take 9 as common thing, I'll get secant square A minus tan square A. We know that 1 plus tan square A is secant square A. If you transpose tan square A to the right hand side, I'll be getting secant square A minus tan square A. So this becomes 9 times of 1, which will be equal to 9. Therefore, the correct option is option B. Second one, we have given 1 plus tan theta plus secant theta multiplied to 1 plus cot theta minus cosecant theta. What I do is, I'll just multiply them. Once it is multiplied, then I will express in terms of sine and cos, so that I may get some identity. So I'll take the given. The given is 1 plus tan theta plus secant theta to be multiplied with 1 plus cot theta minus cosecant theta. If 1 is multiplied to all the three terms, we get 1 plus cot theta minus cosecant theta plus tan theta multiplied to these three terms, I'll get tan theta plus tan theta into cot theta minus tan theta into cosecant theta. Now tan theta is multiplied to all the three terms. Now I'll continue with secant theta multiplied to all the three terms. I'll get secant theta plus secant theta into cot theta minus secant theta into cosecant theta. The best possible way to solve this is to express in terms of sine and cos. So 1 plus cot theta I'll write as cos theta by sine theta minus this particular cosecant theta is nothing but 1 by sine theta plus tan theta is sine theta by cos theta plus tan theta is sine theta by cos theta multiplied to cos theta by sine theta minus sine theta by cos theta into 1 by sine theta plus secant theta is nothing but 1 by cos theta plus 1 by cos theta multiplied to cos theta by sine theta minus 1 by cos theta multiplied to 1 by sine theta. Observe certain things may get cancelled. Let me see which are the terms will get cancelled. Here sine theta, cos theta, they get cancelled here. Here one of the sine theta is getting cancelled. Here one of the cos theta is getting cancelled. The remaining terms I'll write. The remaining terms are 1 plus cos theta by sine theta minus one by sine theta plus sine theta by cos theta. This is sine theta by cos theta. Here everything is cancelled. We get it as plus 1 minus 1 by cos theta plus 1 by cos theta plus 1 by sine theta minus 1 by cos theta into sine theta. These are the terms remaining now. Once again you observe some of the terms are getting cancelled here. Minus 1 by sin theta and plus 1 by sin theta, they get cancelled. Positive 1 by cos theta and negative 1 by cos theta also getting cancelled. What are the things left out now? 1 plus 1, it becomes 2 plus cos theta by sin theta plus sin theta by cos theta minus 1 by cos theta sin theta. These are the terms which are remaining now. Now I'll do a small thing. The 2 I'll keep it as it is. In these terms I'll take the LCM. So 2 plus the LCM is sin theta cos theta. When cos theta is there here, it becomes cos square theta plus sin square theta minus 1. We all know that sin square theta plus cos square theta is 1. So 1 minus 1 is 0. 0 by some number, something will be 0. So we get 2 plus 0, which is equal to 2. So the correct answer is option C. 2 is the answer. It's very difficult to guess the answer. This is the best possible thing which we can do. Let's take up the third one. In the third one, it is given that secant A plus tan A multiplied to 1 minus sin A. Here you should have an hint that one of the term is sine, so it's better converting these things, secant, tan in terms of sine and cos. So we get this as 1 by cos A plus sin A by cos A multiplied to 1 minus sin A. On taking the LCM here, we get cos A in the denominator, and in the numerator it will be 1 plus sin A. Now look at this. I can write this as divided by 1. Now the numerator, there is something like a plus b into a minus b, which is a square minus b square. So it is 1 minus sin square A divided by cos A. 1 minus sin square A is cos square A divided by cos A. One of the cos will get cancelled and the answer left out is cos A. This is answer option number D. Here we have used the identity sin square A plus cos square A equal to 1. I have expressed 1 minus sin square A as cos square A in this step. Question number 4. In the fourth question, they have given 1 plus tan square A divided by 1 plus cot square A. Both are the left hand side of the identities. 1 plus tan square A is secant square A, 1 plus cot square A is cosecant square A. Now I'll express this as 1 by cos square A, reciprocal relation, divided by 1 by sin square A. The same thing can be expressed as 1 by cos square A multiplied to sin square A by cos square A. This is nothing but sin square A by cos square A. We all know that this is nothing but tan square A. So tan square A is option D is the right answer. Question number 5. Prove the following identities where the angles involved are the acute angles for which the expressions are defined. What type of questions are these? These are the questions you need to consider either LHS proving it as equal to RHS or RHS proving it as equal to LHS. In the first question, I'll consider the left hand side. The left hand side of the equation is cosecant theta minus cot theta whole square. Now I need to get in terms of cos, because in the right hand side it's there in terms of cos only, so that gives me an hint that I'll express in sine and cos way. So cot is written as cos theta by sine theta whole square. Now take the LCM. The LCM is sine theta and the numerator becomes 1 minus cos theta. I need to square. This is same as 1 minus cos theta whole square divided by sine square theta. Sine square theta is 1 minus cos square theta. The numerator we have 1 minus, not plus, it is 1 minus cos theta whole square. Now I'll use the identity. It can be written as 1 plus cos theta into 1 minus cos theta. This is 1 minus cos theta multiplied to the same thing because it is whole square. Observe these two terms, they get cancelled and we get 1 minus cos theta upon 1 plus cos theta. This is what is there in the right hand side. Therefore, the left hand side has become equal to the right hand side, hence proved. Second question. Again, I'll consider the left hand side. In the left hand side, it is cos A upon 1 plus sine A plus 1 plus sine A upon cos A. Let us take the LCM. If the LCM is taken, we get 1 plus sine A multiplied to cos A. Here it becomes cos square A plus 1 plus sine A whole square. Let us expand this 1 plus sine A whole square. We get cos square A plus 1 plus sine square A plus 2 times of sine A square plus B square plus 2AB. Here A is 1, so it is 2 times of sine A only, divided by 1 plus sine A multiplied to cos A. Here observe, cos square A added to sine square A, it becomes 1. So 1 added to 1 will be 2 plus 2 times of sine A divided by 1 plus sine A into cos A. So 2 taken common, 1 plus sine A divided by 1 plus sine A into cos A. Now these two terms they get cancelled. We get 2 times of 1 by cos A. It's a reciprocal of secant, so it becomes 2 times of secant A, nothing but the right hand side. Here we got LHS equal to RHS. I'll tell you an important thing. While solving the questions of trigonometry which are of this type, we should never leave our patience. We should not multiply this cos A with 1 plus sine A. If we had multiplied, these terms wouldn't have been cancelled. So you should have a patience and solve till the end. Then only certain terms will get cancelled and easier way we get the answer. Otherwise it's like we'll be beating around the bush. So let's take up the next one. Question number 3. They have given an interior. Write the expression in terms of sine theta and cos theta. Let's make use of the hint and take left hand side. In the left hand side we have tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta. Let me express now tan theta as sin theta by cos theta divided by 1 minus cos theta upon sin theta plus cot theta is cos theta upon sin theta divided by 1 minus sin theta by cos theta. The best thing next what we should do is to take the LCM in the denominator. Once the LCM is taken, it becomes sin theta minus cos theta. Here it becomes cos theta minus sin theta. Since it's a fraction, division of two fractions, we reciprocal the denominator and multiply. I'll follow that thing. I'll write this as sin theta by cos theta multiply to sin theta by sin theta minus cos theta plus the same thing done here, cos theta by sin theta multiply to cos theta divided by cos theta minus sin theta. Now I'll follow a trick. What is a trick? Here you observe there is positive sign. Here we have cos theta minus sin theta. In this particular thing we have sin theta minus cos theta. Here it's reversed. I can make this as same just by multiplying negative. So I will write this expression as sin square theta divided by cos theta into sin theta minus cos theta. Now it's very important. This step is very important. I am not taking positive, I am taking negative. Cos square theta divided by sin theta multiplied to, I will write sin theta minus cos theta. Did you understand the change? Here these things are changed. I have changed this, I have changed this too. Instead of positive, I have made it as negative. Let's continue the steps now. Now I'll take the LCM. By taking the LCM, we get sin square multiplied to one more sin, it becomes sin cube theta minus cos cube theta divided by sin theta cos theta into sin theta minus cos theta. Remember, it is like a cube minus b cube in the numerator. We all know that a cube minus b cube is a minus b multiplied to a square plus b square minus ab, sorry, plus ab. Whenever negative is there here, we get a minus b and rest of the terms are positive. This we had learned in class 9th. Let's use that. We get sin theta minus cos theta into sin square theta plus cos square theta plus sin theta cos theta. Denominator is sin theta into cos theta multiplied to sin theta minus cos theta. Once again, I want you to observe sin theta minus cos theta, they get cancelled. In the next step, I'll write the sin square theta plus cos square theta as 1 plus sin theta cos theta divided by sin theta into cos theta. Let us now take this as 1 upon sin theta cos theta plus sin theta cos theta divided by sin theta cos theta. I have divided the terms respectively. You can check back. If you take the LCM, we'll get the previous step only. 1 upon sin theta is nothing but cosecant theta. 1 upon cos theta is nothing but secant theta. This particular thing is 1 because they get cancelled. You observe it's the same thing we got which is there in the right hand side. So this is equal to right hand side. Therefore, left hand side and right hand side are equal. Understood? It's very important to be patient while solving the questions related to trigonometric identities. At a go, we may not get answers. We need to strive hard to get the result. With this question, I'll end today's session. The remaining questions we shall see in the next session. Thank you.